Hello everyone. In this video, we are going to discuss about global data flow analysis. In order to do the code optimization and code generation, a compiler has to collect information about the entire program and to distribute it to the each block in the flow graph. So, if we are performing some transformations within a basic block, then it is called as local transformations. And if we are performing to the entire block flow graph, that is all the basic blocks, means it is called as global. And in this video we are going to discuss about global data flow analysis. So if we want to perform some code optimization techniques like constant folding and dead code elimination, then we should know where the particular variable was defined previously, in which location it is defined, whether it is live or not. So these are called as data flow information, and these informations can be collected with the help of the process called data flow analysis. So it is here we are going to discuss about global data flow analysis, because the information is distributed or shared among all the basic blocks in the flow graph. So the data flow informations can be collected with the help of data flow equation. So here out of S is equal to gen of S union in of S minus kill of S. So where out of S represents information at the end of S. What are all the informations, data flow informations available at the end of S? It's is represented by out of S. Gen of S means informations generated by the statement S. In of S means informations enters at the beginning of the statement S, and kill of S represents informations killed by S. So out of S, what are all the informations available at the end of a statement S can be calculated by gen of S, the informations generated by the particular statement S union, because that informations will be definitely available at the end of statement S, right? Because it is generated within that statement only. Union. So gen of S union, some informations may come, maybe the input for the statement that may come from the previous statements or previous block. So in of S, but from the in of S some information might be killed. So that out of S means the statements informations which are generated is in S union the informations which are not killed. It is incoming informations, but it is not killed. So out of S is gen of S union in of S minus kill of S. Then we should know about the two terms points and paths. Within a basic block B, there is a point between two adjacent statements. So consider this basic block B1. Here this is a flow graph. It has three basic blocks B1, B2, B3, and there is a loop from B2 to B3. Okay, B2, B3, then from B3 again it goes to B2. So this is a loop, and here B1 has three statements. So there is a point between two adjacent statements, means here there must be a point and here is also a point. But B1 has 4 points because before D1 there must be an point, and after D3 also a point is there. So totally 4 points before D1, in between D1 and D2, then between D2 and D3, and finally after D3. So there are 4 points in block B1. Similarly in block B2 there are 2 points. Then the next term is path. A path from P1 to Pn, P1, P2 up to Pn, these are the points. Okay, so a path from point P1 to Pn is a sequence of points P1, P2 up to Pn, such that for each I between 1 and n minus 1, from P1 to Pn minus 1, either of these two conditions hold. Pi is a point immediately preceding a statement, and Pi plus 1 is a point immediately following that statement in the same block. So the meaning of this one is Pi and Pi plus 1, that is P2, P3 or P3, P4, these are the two adjacent points. So that is given by the first statement. Second one is Pi is end of some block and Pi plus 1 is the beginning of a successor block. Okay. So that in this example, we can say that a path from B1 to B2, because here Pi, here there is a point. So this point, from this point to this point, a path is there. Therefore, here Pi is the end of block B1, and Pi plus 1 is the beginning of successor block. Here B2 is a successor for B1. So we can say that there is a path from this point to this point, B1 to B2. Okay, and another example, we can say that a path is exists from beginning of B3 to beginning of B2 in the same example. So there is a path from beginning of B3 to beginning of B2. So if there is a path means the point should be adjacent points, right? So beginning of B3, we can reach from the beginning of B3 to beginning of end of B3. Then from the end of B3 there is a path is there. So from the end of B3 we can reach the beginning of B2. So we can say that a path is from beginning of B3 to beginning of B2. Then next one is reaching definition. A definition of a variable x is a statement that assigns a value of x. So we can here D1 is a definition of I, because it assigns a value to I. Similarly, D2 is a definition of j, D3 is a definition of I, etc. So a definition means, definition of a variable x means it is a normally an assignment statement that assigns a value to this variable x. Then a definition of D reaches a point P. Definition of D can be reached to point P if there must be a point from D to P. Okay, such that D is not killed along the path. And killed means a variable A is killed if between 2 points along the path there is a definition of A. Okay, so a definition of D reaches a point P if there is a path from D to P and the condition is D is not killed along the path. Killed means if there is another assignment in between the 2 points. For example, here A is assigned as 3, the next statement uses A, so B equal to A plus 2, and here A is redefined. So A is equal to X plus Y and C is using A. So which A is used here? The previously defined A. So this A is not reaching this the final statement. Okay, so we can say that a definition reaches the point P if there is a path as well as it is not killed along the path. But here this statement killed the previous A. Okay. Next subtopic is data flow analysis of structured programs. So this is a grammar for the structured program. So a statement may be an assignment statement, a sequence of statements, and a statement may be if then else statement, if E then yes, else yes, and it may be a do while statement, and this expression can be an addition expression or simply an identifier. So this is the diagrammatic representation. So this is for a sequence of statements, two statements. So S1 followed by S2, and this is for if E then yes, else yes. So first expression is evaluated. If it is true, this path is executing, that is go to S1. So S1, the statement S1 will be executed, otherwise statement S2 will be executed. And in do while statement, first the statement S1 is executed only once, then it checks the expression. If it is true, again the same statement will be executed. This is the loop. So now we are going to discuss about data flow equations for reaching definitions for all the structured programs. So here consider only one statement. A statement may be simply an assignment statement. Okay, S equals ID, S tends to ID equals E. S tends to this is the left side of the equation, the rule. Okay, so S tends to A equals B plus C. The name of this definition is D. Okay, So here we are going to discuss about all the attributes, gen, kill, in and out. Okay, and gen, kill, these are all the synthesized attribute. Normally in is a inherited attribute in this data flow equations. So gen of yes, gen of the statement yes means here which statement is generated, the definition D. So gen of yes is D. Then kill of yes. So what about kill of yes? All the previous definitions for A will be killed except this newly generated D, right? So from DA represents previously generated definitions for A. So DA minus D is the kill of the statement yes. Then out of yes, this we have already know. Out of yes means gen of yes union in of yes minus kill of yes. This equation we have already discussed in the equation, data flow equation. So out of yes means all the statements generated in that statement yes union in minus kill. Then a statement may be two statements, two adjacent statements, S1 and S2. So hereafter we are going to discuss about gen, kill, in of S1 and S2. In should be calculated for right hand side of the rule, context free grammar, and other attributes must be calculated for the left side. So here S tends to S1 colon S2. The second context free rule, S tends to S1 colon S1 semicolon S2. So we have to calculate gen of S, kill of S, in of S1, in of S2, then out of S. Okay. So gen of S. What is gen of S? Generated the statements which are generated in S. Data flow informations generated in S is equal to gen of S2 union gen of S1 minus kill of S2. Okay, so gen of S means all the informations which are generated in S2 union informations which are generated in S1, but it may be some informations may be killed in S2. So that S2 union, gen of S2 union, gen of S1 minus kill of S2. Similarly, kill of S, if you want to find kill of S, then it is kill of S2. All the informations which are killed in S2 union, kill of S1 minus gen of S2. Some informations which are killed in S1 may be generated in S2. So that is written like kill of S1 minus gen of S2. Then in of S1. What is in of S1? In of S. In of S1 is in of S, and in of S2 is out of S1. Okay, then out of S is out of S2. Out of S is equal to out of S2. Then for if then else statement, S tends to if E then S1 else S2. Here gen of S. Gen of S means here it can follow either this path or this path. So generate the data flow informations generated in this path union this path. So gen of S is gen of S1 union gen of S2. And kill of S is kill of S1 intersection kill of S2, because kill of S1 means all the statements which are killed in S1, sometimes something may be generated here, so that kill of S1 intersection kill of S2 should be performed. Then what about in of S1? In of S1 is in of S. Then in of S2 is also in of S. And out of S is out of S1 union out of S2. Then for while, do while loop, gen of S means gen of S1. All the informations which are generated inside S1 is gen of S. So gen of S is equal to gen of S1. Similarly, kill of S is also kill of S1. Then in of S1. What about in of S1? All the informations which are inserted at the beginning, that is S. So in of S1 is equal to in of S, as well as after completing one execution of the block, it will check the condition and again the same block will be repeated, right? So union gen of S1. Gen of S1 will also be given as input to the in of S1. So in of S1 is both in of S as well as gen of S1. Then out of S is equal to out of S1. So These are the global data flow analysis. Thank you.